Alrighty, so on Friday, we talked about uniform distributions and the continuous distributions with like triangles, trapezoids, rectangles, that kind of stuff in it. And this is the only question that we didn't get done in the notes. So while we wait for the rest of the class to get signed in and situated, I'll give you guys about 5 minutes to answer questions A, B, and C on the very last example number 2. In the uniform distribution section where it says time it takes for students to drive to school is evenly distributed with a minimum of 5 minutes and a range of 35 minutes. So practice that, answer these 3 questions, sketch out your distribution, and see what you remember from Friday, because we did have a 3-day weekend, so I'm sure you forgot some things. But then once you guys are good to go on this, then we will talk about normal distributions, which go pretty quick because the calculator will do most of it for us. Anyways. Go ahead, see what you remember from Friday with these, and then we'll get started. Good morning, sir. Good morning, sir. All right. So again, last time we learned with these uniform distributions, if it tells you right here that if something is evenly distributed or uniformly distributed, it's going to be a rectangle. So when you draw the distribution for A, all right, draw yourself a rectangle, a minimum of 5, meaning that your lowest number on the left side is going to be a 5. And then it says a range of 35. So you add those together, and that means your right side will end up at a 40. All right, so that'll kind of get you the idea of how far the rectangle goes. Again, this can just be a sketch. We're not looking for, presentation grade, drawings every time. The height, remember, is always going to be 1 over whatever the range is, because we learned last time that the area of the whole rectangle is equal to 1. So that means 1 is equal to the height times the range. So if we do a little bit of algebra, 1 over r will always be the height of the rectangle. So in this case, you got 1 over 35. So if you know what your range is, you know what your height is. Now you can start answering your questions as far as, how much is going to be more than, less than, all that stuff. Just make sure you write out your probability statements in the right way. So what is the probability that it takes less than 20 minutes to drive to school? So that's asking for x to be less than 20. Don't forget, on Friday, we learned that it doesn't matter if it's just a less than or equal to symbol. It's not going to change anything. So basically, you're looking for this area of the rectangle here. So we know what the distance is at the bottom. We know what the height is, so we can multiply those two. And that's it. Our answer is 0.4286. All right, any questions on that? All right, so again, uniform distributions are always rectangles. There's things about them that'll always be true. Like say, this is the range. Sorry, guys, I don't know why it's twitching in class. What is the average and standard deviation for this distribution? So the average is just the upper and lower limit added together and divided by 2. So like you would take any average between two numbers. So 22.5 minutes is the average here. Don't forget to put your units on the average and standard deviation stuff. And then standard deviation is the largest minus the smallest, so that you get a positive numbers, which is 35, divided by the square root of 12. It's always going to be this number right here. All right, so we're going to get equal to 10.1036 minutes. Again, any questions on this? We okay with this? Before we move on to the normal stuff. What's up, Miss Elizabeth? Okay, so normal distribution. So we've seen where we can have rectangles, trapezoids, and triangles. What happens if the graph itself is not straight? What if it's got a curvature? Well, one of two things happens. Either it gets really crazy and it curves all over the place, and you would need the fancy calculus to figure it out, which we're not going to do. Or scenario number 2, it's what we call a normal distribution. So a normal distribution, if you remember way back in September, it rhymes. It's a symmetrical bell-shaped density curve. So it looks like it's a little bell. So it is symmetrical, which is going to be helpful to us. The notation for it is similar to what we had for like the binomial or geometric. There is a little parentheses thing. It's the capital N to identify that it's a normal curve, and then it has the average and standard deviation next to it. The transition points, or what we sometimes call inflection points, occur at the average plus or minus a standard deviation. So for the first part of the normal distribution, we're going to talk about the empirical rule. That's where the standard deviation is exactly 1, 2, or 3 positive or minus from the average. The probability is calculated by finding, again, the area under the curve. As the standard deviation increases or gets further away from the average, it can be in both the positive or negative direction, your curve is going to get flatter and it's going to spread out more because there's less data under that area. Again, as the standard deviation gets closer to the average, the graph is going to get taller because there's more area, or sorry, there's more data underneath that part of the area. All right, so there's a calculator image on the bottom right there of what a normal curve would look like. So this is the very middle of it. This is where your average is located. That's the whole point behind these things. And then as you go further this way or further this way, the standard deviation increases, either positive or negative, and the data becomes less and less. So therefore the graph gets flatter and more spread out. You guys have seen these before, so this is kind of a review. There's another picture of one there. And then there you go. The calculator is being weird. There's another picture of there. So all of these could be normal curves. It doesn't matter which one we're looking at. So does the two normal curves here have the same mean? Got some people shaking their head. Yes, that would be true. Yes. They're both centered at the same location. So it doesn't matter if the graph's really tall or skinny, or really flat and spread out. If their center is at the same location, then they have the same mean. Which normal curve has a standard deviation of 3? Which normal curve has a standard deviation of 1? Remember, standard deviation is a measure of how far from the average we would find an average data point. So the larger the number, then the more spread out we would assume the data is in the graph. So graph B, the flatter one that's more taking up more space horizontally, would be the one with the higher standard deviation, and then the one that is a little bit more taller and narrow is going to be the one with the smaller standard deviation. So things to keep in mind when you're looking at numbers and stuff in the data then. All right, so the empirical rule, this is already listed in your notes, but and I think we kind of talked about this briefly in the fall, but if not, here's a refresher. Empirical rule states that 68% of observations fall within 1 standard deviation of the average, 95 within 2 standard deviations, and 99.7 within 3 standard deviations. This is true for all bell-shaped curves that are approximately normal. Okay, so if you see that phrase anywhere in the paragraph, then you can use this stuff. So right above these little things in your notes, it says only applies to normal distribution. This does not work with the rectangles. This does not work with the triangles, that kind of stuff. Only with these normal distributions. All right, so let's do an example together so you guys can see kind of how this works. And then we'll talk a little bit more about what happens when the standard deviations aren't perfect, because in life, things don't always fit on the formula. So suppose that the height of male students at Plano West Senior High is normally distributed with a mean of 71 inches and a standard deviation of 2.5. What is the probability that the height of a randomly selected male student is more than 73.5 inches? So when you see a number that's very specific like this, you're probably going to be using the empirical rule, because these kind of numbers only come from adding or subtracting the standard deviation exactly by 1, 2, or 3 on our deal. So our little graph is going to look like this. Remember, our average is 71. So right here in the middle is going to be where we locate our average. 68% of the data is going to be in this middle section here, both above and below the average. Okay, so this whole section here, 68% of people fall into this. So if you're going to go into the medical field, or you do psychology or anything like that, you're going to use these normal curves all the time, because typically when you generalize human characteristics, they fall under a normal curve. So that's why we usually use examples with height, weight, that kind of stuff. All right, so to find the percentage that's left over, all right, on either side of the graph, we can do a little bit of math here and kind of figure out the remaining area that's going to be located here in these sections. So 68% of the data is in the middle. We're looking for how much is on these sections again, because this is the first standard deviation out. So how do I know I'm at the first standard deviation? Well, what is 71 plus 2.5? That answer right there. So that tells me I'm 1 standard deviation to the right or above the average. All right, like I said, if these numbers are nice and pretty, or seem to be equal to something that we could just add up, then that's what you are looking at. So again, your average here is 71. This is your average. This is your standard deviation here. So if I add these together, 71 plus 2.5, all right, that's where I get this number here from, 73.5. So I added 1 standard deviation, so that's where I'm at right over here. All right, so just in case you're like, how do you know where to draw the graph? That's why. All right, so now I want to know the probability that X is greater than 73.5. Well, I have 32% of my data not accounted for in this first section. And the graph is symmetrical, so 32% is what's left over of the whole graph. I just want the upper half, where the data is more than the 73.5, so that's 16%. So that's mathematically one way to do it. You could draw out, like we did in September, the whole graph and number everything if you wanted to. It just might take you a while, so we're kind of trying to do this mathematically. Questions on anything I did here? Sorry that the screen's being all glitchy here. All right. Everybody looks like they're sleepy and ready to go. All right, so we're going to continue here. All right, are all normal probabilities or these types of problems going to be exactly 1, 2, or 3 standard deviations from the mean? No, they're not, unfortunately not going to be. So this is where our nice little fancy calculator that we spent money on or get to borrow from class comes in handy, because it does have a program like the binomial and like the geometric to help us out. The normal curve is also not a standard shape we use, that we can use geometry to find the area of either. that means we have to standardize our values using z-scores, right? And use a special table to find the probability. So I'll show you guys the table. It's in my email. I need to upload it into Canvas for you guys. And then I'll show you guys the calculator steps as well. All right, so standard normal density curves always has a shape, again, of this is my average and this is my standard deviation. So what does that mean? Always has average of 0 and a standard deviation 1. It means if I reset the graph to its default settings and try to compare it to other graphs of similar shape, this is where I'd reset it to. Now, the average and standard deviation will obviously change depending on the scenario you're looking at, but this is the default reset setting. You'll see it in your calculator. This is what your chart is based on as well. And while you guys are writing that down, I'll look for the chart real quick because I forgot to upload it this morning. Not that you need the chart, your calculator works better, but for those of you guys that are curious about what the chart looks like, I'll show you in a second. There you go, there's the chart. I'll put it back up in a second. All right, to standardize it, you use this formula. You guys may remember this from the fall. Again, depends on how much you remember from way back in September. Typically, you are expected to memorize this formula. However, this year, remember, you have your notes and stuff, at least for our quizzes. So highlight this, write this down so that it's handy. But when it comes to the AP exam, they probably won't give you this one because it's one that in the past they've expected to memorize. All right, so for the first couple examples here, example 2 that we go through, I'm going to show you guys how you would do this on the chart using the z-score formula that you see in front of you, and then we'll do it through the calculator, and you guys can see that, yay, we have calculators to make our lives much more easy. Like I said, have this memorized. You're going to use it enough that it's going to happen accidentally, but just keep that in mind because they don't always provide you this formula on the AP exam, just as a heads up. All right, so let's look at an example. Lifetime of a certain type of battery is normally distributed. So there's your clue, what you're kind of working with here. With an average of 200 hours and a standard deviation of 15, what proportion of these batteries can be expected to last more than 220 hours? So what I have to do is standardize this data to fit on my graph that has 0 as its average and 1 as its standard deviation. So what I'm going to do is convert basically from these numbers to that standardization using what we call the z-score formula, which is what you guys just memorized. All right, so first off, write your probability statement. So what is it that we want on this one? We want to know proportion of batteries that it could be expected to last less than 220. So our X should be less than 220. So start with that, just so you know what you're doing. Because otherwise, you're going to be like, what am I solving for? All right, this number becomes your X value. So if you remember your formula, it says your z-score is equal to the X value minus the average divided by the standard deviation. All right, draw and shade your curve if you're a visual learner. All right, does this mean I'm going to go to Emily's paper every question to make sure she drew it? No. All right, if she understands how it works in her brain, then it is what it is. Excuse me, I'm just trying to get you guys to kind of visualize. What are we looking at on the graph? We're looking at this bar and everything to the left. Okay, well, how do I know that this bar is over here at this spot and not somewhere else? Because the average is 200, which goes right down the middle. So 220 is going to be a little bit bigger than that. So I just guessed somewhere on the right side where the bar might be, and then I shaded everything to the left side. So that's what I'm looking for. That's the area under the curve that I care about on this problem. All right, so first off, again, calculate your z-score. So it should be like this. All right, z equals 220 minus 200 divided by 15. So that's 20 divided by 15, which is 1.33. So why do I care about 1.33? What does that tell me, Mr. G? Well, if you kick it old school, and most of your professors in college still believe in the table I'm about to show you, then what you do is you look at this table and you find where 1.33 is located on the table, and you go across and you're going to see a bunch of percentages, and you find yours, and that's the answer to your question. All right, so let me show you the table real quick. So our z-score is 1.33. Any questions on how I got that? We okay there? Okay. So here's your table. I'll upload this to Canvas later, so if you want to look at it, you can. Luckily, we have a calculator, so you don't have to do this every time, but this is the old school way of doing it. All right, so 1.33 was my z-score. So I go down to here. I'm on the positive because it goes both positive and negative. So I'm on the positive half of this table. I go down to 1.3, and then I go over to the other 3 because that'll give me 1.33. So this is the ones place and the tens place, and this is the hundreds place. That's all I care about when I do these z-scores. So 1.33 gives me this number right here. So that what it tells me is the area to the left of the graph underneath that z-score is 0.90824. So about 90% to 91% of whatever I was just talking about is going to last less than 220 hours. So I think we were talking about batteries. Okay, so that's how you would use this table. So I go back and I look, okay, there's my z-score. Look it up on the table, we just did. Boom, there's my answer. That's the old school way to do it. Our calculator is going to do all this for you in just a second. And our calculator is actually more accurate because if you notice with that table that I just disappeared over, all right, you're kind of limited, right? What if you get 0.135? Well, now you got to kind of do like an average between these two numbers. Okay? It works for the most part because these percentages don't change that drastically between the two, but that's how they did it for years. Again, luckily our calculator has all that programmed into it. You just type it in there, I'll show you guys, and you'll be able to find these answers. All right, what about more than 220? Well, if I already figured out what the z-score is at this x value, it doesn't matter which way my probability statement is going, left, right, equal to, greater than, whatever. The x is still going to be the same in the equation. So it's still going to be 220 minus 200 divided by 15, except now I'm shading it on this side. Well, wait a second, Mr. G, then how do I know which percentage to use on that table? Well, the table always is built. If you're going to use the table, if you go to college, your professor makes you use the table. This table is always built with area to the left of the z-score. So if I want area to the right, then what I've got to figure out is, okay, what percentage is to the left, and then do 1 minus that. Well, we already figured out what is to the left from earlier. It's 0.90824. So if we subtract that from 1, then we can get the area to the right. So in this case, 0.0918% of batteries, or at that decimal rate, so about 9% of batteries would be expected to last more than 220 hours. This is another limitation of the table, is that it always goes to the left. And they just kind of let you figure out what you needed. What if you needed something in the middle? Well, then, you know, you'd have to subtract the difference between the two. It's all possible to do. It's just a little tiresome, a little tedious. All right, so again, before we work at some more algebraic style questions coming up on the next 2 examples, any questions so far on what we're doing with the z-scores? Okay with this? Again, keep in mind that in a second, I'll show you guys the calculator. You won't even have to look at this table if you don't want to. It is kind of cool though, if you like to be like, you know, retro on something. Like, look at me, I get to use the table. A lot of your professors will use the table just because they're stuck in the mud on that. They don't have these nice calculators at whatever university you go to because they're not providing them to you. So they just use the table. But if you guys have one of these calculators, you could use them to do your statistics. All right, so what if we kind of change up the answer in the question just a little bit? How long must a battery last to be in the top 5%? So now we don't have an X value given to us to just plug into the formula and calculate the z-score and do our thing. We're actually looking for the X value this time. So this is where a little bit of algebra comes in. So I know my percentage. All right, so I know some X value has to be greater than whatever in order to give me the top 5%. So some area to the right has to be shaded at exactly 5%. So what I do is I reverse engineer the table if I got a question like this and I was stuck with the table, and figure out what z-score exists at this 5% on the table. All right, let me get to the point where, okay, so yeah, remember your table goes to the left. So what actually would I be looking up on the table instead of 5%? 0.95. All right, so find the closest probability to 0.95 to find the z-score. So this is where the table can kind of be limited because, again, you're not necessarily going to find 0.95 exactly. So I load up the table. I've got all of these percentages floating around everywhere. I need to find in this mass of decimals 0.95. Don't even worry about the top and bottom rows yet. Just look for 0.95 in this. And I didn't do this earlier. So here we go. I'm kind of limited right here. Here's my closest to. between 0.9495 and 0.9505. So I'm probably going to go right down the middle and say this is, instead of a 0.04 or a 0.05, that it's 0.045. All right, so where was I at? I got to remember what row I was on. This row right here. All right, so it's 1.6. And then we said at the top, it's not really 4, it's not really 5, it's really 4, 5. So it's 1.645 is what I would call it in order to find 95% exactly. That's about halfway between these two things here. So that's how you would reverse engineer it. So again, you know you're kind of floating right here in this space. You go back over and you look and say, okay, the first two numbers are 1.6. And then again, as I go up here, I can kind of see I'm between the 04 and the 05. So this would be 045, kind of like right here. So 1.645 would be what I would get for my table on that one. That's what we put in the notes. Again, it's not perfect. It's close. And that's the limitations of the table. So we know that's where that little standard deviation is happening. That's dividing up my percentages between 5% and 95%. So now that I have a z-score, and I already know the average and standard deviation from the problem, because the average is 200, the standard deviation is 15, I can use this equation again and just do a little bit of algebra to figure out my missing number. So you multiply these two things here, 1.645 times 15. You're going to get it equals this equation. Well, it's a negative 200 over here, so we add 200 to both sides. This cancels out. We're left with just our x at 224.675. Again, your calculator will do this for you, but I'm just letting you guys see how it works the old school way. So you don't always have to get all three pieces of information. You can kind of reverse engineer this as needed to find what's missing. And don't be surprised if one of those questions kind of pops up on you. All right, one more example to look at, and then we'll talk about the calculator steps. Or maybe not, maybe they took that example out of the notes. Oh, she moved that to the end, never mind. All right, so we'll get that. Example number 3 actually goes at the end. She told me that the other day. She moved things on me after I printed everything out. All right, will my calculator do any of this normal stuff? Yes. All right, so I'm gonna grab my calculator. If you guys have yours, get it ready, and I'll show you. You go into second vars, just like you did for your binomial and geometric. So if you didn't know how to do that for your binomial and geometric, then obviously, you know, your first quiz needs to be taken care of. There's a normal CDF and a normal PDF and all that stuff that's inside there. So second vars, they're at the very top of this one, which is nice. You will never use the normal PDF because we're not looking for an exact X value on these things. The normal PDF is basically just the z-score formula. You can do that on your own. You don't need that one. All right. You will use the normal CDF to help you find probability or area. All right, so if it's asking you a question like what percentage of batteries last less than this, or which percentage of people are taller than this, that's telling you I need to find probability. I'm going to use normal CDF. You're going to type in a lower and upper bound. I'll show you guys how to do this on the camera in just a second. All right, for the lower and upper bound, sometimes you use what we call the calculator's version of infinity. Because you don't really know what your upper and lower limit is. You know, it just kind of keeps going in that direction. So I'll show you guys how do you type that into the calculator so you know what you're doing. The other function we might use is right below it, option number 3 in my calculator. It's called inv norm or inverse normal. This will help you find the z-score or the x value if you're given the probability and you want to solve in reverse. So like our last question where it said you have 5% of batteries and you want to find the answer from that, you can go in reverse using the inverse normal. You have to give the calculated area below the z or the x if you're using the older calculator. If you're using our newer ones that let you do all kinds of cool stuff, you can do right, left, center, whatever. Okay, so depending on your calculator, you may be stuck with doing only to the left unless you have one of the newer versions. So keep that in mind. You may not have everything that my calculator has just because they've updated it since the older one. So I'm looking at people with the older TI-84s, the little fat ones, or the TI-83s for sure will only do to the left. But other ones will do, the newer ones will do center and right. So it just kind of depends on what you got. So keep that in mind as we're going through this. All right, the calculator doesn't require you to convert a z-score except when finding the average or standard deviation, and it's more accurate than the table. So what I mean is on the table, we were limited to trying to find the difference between the two numbers. Like, it's kind of close here. Your calculator has the exact number in there because it's smart in this case. So you don't have to worry about rounding or anything like that. You just type in exactly what you need. All right, so let's practice this with the calculator. I'll show you guys all the steps here in just a second. So the lifetime of a certain battery, type of battery, is normally distributed with an average of 200 and a standard deviation of 15. What proportion of these batteries can be expected to last less than 220? So first thing you got to figure out is, am I looking for a percentage or am I looking for like an X or a Z score? I'm looking for a percentage on this one, right? So that means I'm going to use option number 2, which is the normal CDF. All right, so let me load up my cameras. All right, so turn on everything, clear everything off if you need to. So hit the second button, hit the VARs button. And again, we already know at the bottom of this is our geometric and our binomial from last section. At the very top, where 1 and 2 and 3 are, these are our functions. We're not going to use 1 because 1's only going to tell us an exact number. We're going to use either 2 or 3. So because I'm looking for a percentage, I'm going to use number 2, and it brings up this screen right here. Okay, Mr. G, what do? Well, you have to decide, are you looking for more or less than something? So what does our problem say here? Less than, very good. So that means our data is going to be going from some point on the right side toward the left side. So if I drew my little normal curve over here, kind of in red, I know it's hard to see in class, sorry. I'm going to be somewhere probably over here or wherever, but I'm going to be shading this way because our probability statement says X is less than, what do we have, 220. So this is important to remember because when it comes to typing things into the calculator, you need to tell it which direction you're going in. So we're already kind of set up where we need to be. The calculator pretty much assumes you're going to the left anyways, unless you tell it differently. So this weird notation, -1E99, means negative infinity. So what we're telling the calculator is we don't know how far the batteries go this way. I mean, we could assume 0. All right, no battery's going to last negative hours. But for the sake of this graph, the data that would be considered for negative hours is so negligible, it's not going to make any difference. So don't get caught up in that. Just leave it at negative infinity and move on with your life. So that's what we're going to put as our lower limit. So this means how far to the left does the graph go? How far to the right does the graph go? Well, if it goes to infinity to the left, where are we stopping over here on the right side? Well, we're stopping at our X value. So we're going to type in 220. So what we're telling the calculator is between these 2 points, how much area is under the curve? Well, it needs 2 more things from you. It needs to know what the average is and what the standard deviation is if you have both. Okay, certain problems you're going to be missing one, and you can't type in just one and forget the other. So you have to have both in order to type it in. In this case, we do. It's 200 is the average, and the standard deviation is 15. That comes from the word problem. Question? All right, once you got it all figured out, you know your lower limit, or you're going to the left forever, you're going to the right up until you get to 220. That's your average, that's your standard deviation. You hit enter a few times. All right, those of you guys with the TI-83 or older TI-84, it should look like this after your parentheses opens up. Okay, that's what that's telling you. And then you press enter, there's our answer. So 0.9088, which is a little bit different than what we got from the chart, but remember the chart is a rounded thing. This is a more accurate. So that's how you would do that one. All right, let's look at the next example. What proportion of these batteries can be expected to last more than 220? Well, again, I'm still looking for a percentage. So we're still going to do second, VARs, and option number 2, because we want to know area under the curve. But we're going to kind of flip these numbers, right? Because we're no longer going to the left forever. We're now stopping at our new lower limit, which is going to be at the 220. All right, so why is that my new lower limit? Because this little inequality has flipped. It's no longer facing this way. It's now facing that way. So what that's telling me is 220 is now my lowest number because it has to be more than that. For the upper limit, we want to type in positive infinity. All right. I guess in theory, a battery can last forever. That's what Energizer claims anyway. We know it's not true, but that's what they claim. So how do I type in infinity? This is where you put in the number 1. And then you hit the second button and the comma button. It's going to bring up the little double E's. This is like to the 10th power or whatever you want used in chemistry. So second, comma, will bring up your little E's. And then 99 is the biggest you can type in. So it's basically 1 with 99 zeros. That's quite a while. I think we'll be good. I think we've covered everything. Did your average and standard deviation change on this problem? Nope, we're still good. All right, we can hit enter a few times and we're all set. So there's our second answer. Now, again, those of you guys with the older calculator, it may not let you go that way. So you might have to do this number here at the top and then just do 1 minus your answer because your calculator limits you to the left. So it's really, you know, you got to play with your technology and figure out what you're stuck with and what you're used to using. So if you can't do upper and lower limits and figure things out to the right because your calculator is older, then you have to outsmart it, is what I'm saying. All right, again, any questions on this one before we do the last example? And then I'll let you guys practice one and we'll see how we do. We okay with this for early Tuesday morning? Okay, what if we want to do the last example? The lifetime of a certain battery type is normally distributed with an average of 200 and a standard deviation of 15. How long must the battery last to be in the top 5%? Okay, so now we're not looking for percentage. What are we looking for? X value. So this means you're going to hit the second button, hit vars, go down to the inverse normal. This is where our in-class calculators and one similar to this that you guys own are really nice. Like they're worth the investment if you're going to do more statistics in the future. All right. First thing you want to do is type in the area that you care about. I care about the top 5%, so that's 0.05. It has to be in as a decimal. What is my average and standard deviation for this problem? It is still 215. If I don't have one or both of these, then you leave it at 0 and 1. So it depends on what you got. If you leave it at 0 and 1, then you got to plug it into the formula and reverse engineer it. Now, the nice thing about these newer calculators is they offer the option to go left, center, or right. The older ones do not. So the older ones just assume if it doesn't have this as an option that you're going to the left. And then you'd have to do 1 minus whatever you're figuring out. Okay, we can say that we want to go to the right. How do I know it's to the right? Because it says the top 5%. If you look at your normal curve, all right, here's kind of a rough picture over here. It starts at 0%, and then as it goes this way to the right, it adds data to it. So for percentiles, all right, if somebody wants to ask, hey, I'm in the top 10% of students, you're over here on this side. Okay, so just so you guys kind of know which direction you're supposed to be going in. Hit paste, and then it's going to give you the answer of what X should be at that spot. So it should be 224.6728 hours. Pretty neat because normally you'd have to go find the chart and then do like we did with the chart. You have to kind of guesstimate the difference between the two and then plug it back in. Not that it's hard, it's just tedious. This way it takes all the tediousness out of it. Just type in your answers and press enter.
So then how would you do it just like
So it's going to assume that it's probably to the left is going to be my guess. So you can do one of two things. So you decide which way you want to go on this one, Hope. So if you don't have the left, center, right options, you know, it's probably just to the left. Either you can leave the percentage at 0.05 and then do 1 minus your answer, because that means, you know, you can figure it out from the other side. Or before you even type in your area, figure out what percentage is to the left. So if I'm 5% to the right, how much is to my left? So just do that. All right. So that's going to be at the exact same spot. And then you just make it'll be to the left on yours, and you'll see we'll get the same answer. So that's probably the easiest way to do it is just fix the percentage first before you even type it in. That's what I would do, because they're going to be at the same location. 95% to the left is the same as 5% to the right. So good question. All right. Any other questions? Okay. Then I'm going to put up example number 5 on the screen. Let you guys practice A through G. We didn't go over how to do all of them, so I'll let you try them first, and then we'll go from there. We'll see what time we got. All right, there's your question. So on your own, Joan found that her average telephone call last month was 9.6 minutes with a standard deviation of 2.4. Her telephone call usage was approximately normal. That's the key. Answer A through Z. I did not talk about how to do F or G necessarily, but some of you guys are very smart and probably figured out before I show you. For you, Hope, if you're doing everything to the left, the last two you have to be extra creative because those require center. So it's okay if you don't get it right away. I'm just giving you a heads up. So you're like, wait, I'm not supposed to. If you need to, draw yourself a graph to help organize your thoughts, if you need to. And don't forget, as you're doing these, get into the habit of writing that probability statement so you know what direction you're going in, and it is required for your answers anyway, so you might as well write it. All right, take about 1 more minute with these, and then we'll go through the answers, and then we will stop here for the day. And then as a reminder, we'll finish up the notes tomorrow, 6 and 7, and then I'll unlock your guys' quiz from whenever it was that we took it last time, I think, and let you guys look at answers on that and ask questions. So that'll be tomorrow's class for those online that are deciding whether or not they want to sign in. We'll do that tomorrow. All right, so let's go over these real quick. So I wrote down on my paper kind of what it was asking for. So here's my graph. We're at 9.6 minutes down the average. Here's my average time. There's my standard deviation. So these should be something similar to what you guys have as your probability statements for each of these. Again, it kind of depends on how you organized it, but this is for the most part what you should be looking at. First couple ones are pretty straightforward. So probability X is less than 5. So on this one, I'm looking for a percentage. So I'm going to do second bars, normal CDF. Lower bound is going to be negative on this one because we don't really have a lower limit that we're worried about. And then for the upper limit, we're going to put in the highest value we'd accept. In this case is going to be 5. All right, for here, you can actually put in both your average and standard deviation. So 9.6 and 2.4. And there you go. There's what I got on the first. 0.0276. All right, again, we're looking for percentage. All right, so if her average is about 9.5 to 10 minutes of phone call time, then yeah, it's not going to be very likely that her call is going to last less than 5 minutes, according to the data that we have. All right, for letter B, we go the other direction. So second VARs, normal CDF. All right, this time our lower limit is the 15 because that's the smallest number we want. Upper limit is going to be the 1, and then second comma to get the E, and then 99 for infinity. If you're going lower limit, just put a negative sign in front of that. Average and standard deviation remain the same. Press enter, and we're going to get 0.0122. All right, any questions on those again? Everything's like wigging up. There we go. Okay. What about letter C? So the question on C said, what proportion of calls were between 4 and 18 minutes? So basically, X is now floating in between 4 and 18. So how do I do that one, Mr. G? It's actually quite nice in these calculators. Second VARs, go to normal CDF. Since you're still looking for percentage, you still use option 2. But now your lower and upper limit are just these numbers. So I know 4 is the smallest phone call I want. 18 is the largest. So I find that the middle, when you're looking for percentage, is actually easier if you're using the calculator here. If you have an older one and you're not quite sure, just let me know. I can work with you. So like for yours, Hope, you'd have to do both to the left, I think, and then just subtract them. That's how it works. You'd have to do 4 to the left and what's the other one? 18 to the left, and then whatever your two answers are, subtract the difference. So you should get 0.98995, which rounds to 0.99, it looks like. All right, again, we okay with that? All right, letter D, probability that X is less than some number is 90%. So we need to figure out what this K is, or this missing number, a little lowercase x or whatever. So when I'm looking for the value, but I'm given the percentage, then I switch gears and I go to number 3. Because now I got to type in an area that I have. So I have 0.9 or 0.90. All right, my average and standard deviation for this are still the same, so still 9.6 and 2.4. Again, if you have both, use them. If you don't have one or the other or neither, then don't do this. We want to go to the left because the question for letter D said represents the 90th percentile. So percentiles measured from the left. So all the way over here would be 0 and across the graph as you go. So we're going to keep it to the left on this one and then paste it, and there we go. So 12.6757. And that's minutes now that we're talking about an actual X value. So at this time, phone call time, you'd be at the 90th percentile. All right, what about the top 15%? Like it says on letter E, to have 15% of calls longer than it. So again, second VARs, option 3 type in your area as 0.15, and now switch it to, you want to go to the right. So I would have 12.0874 minutes. That would be the number I would want to be at 15% or higher, the top 15%. All right, we okay with these? Hopefully. All right, if not tomorrow, because we're getting short on time here, then let me know. All right, let me do the last two before we get to run out of time. So F says, what interval of calls would represent the middle 60? This one's nice because second vars option 3. All right, type in your area as 0.60. Leave your standard deviation average there. And then on these newer calculators, this again, where it becomes a lifesaver, you just type in center. Ta-da, and you're going to get two answers. Two answers are what you want because you're looking for an interval. So between 7.5 minutes-ish, whatever that is, 7.5801. And then on the other one, it's 11.6199. So between those two numbers for X, that's where 60% of your data is at. Pretty cool. All right, last one. For those of you guys that remembered this, excellent. If you forgot, don't forget. So the middle 50% is what your IQR is. Okay, so remember on your box plot, your IQR is this big box here. This is the middle 50% because 25 is here and 25 is there. So same thing as you did before. Second, vars, all right, inverse norm, 0.5. Keep it at center. And this will give you your two anders for your Q1 and this is your Q1 and your Q3. So your lower and upper limits. All right, if you got questions, you can linger a second or two and say, hey, Mr. G, I don't get this. If you think you got it, then that's it for today. Like I said, tomorrow we'll finish up examples 6 and 7, and then we'll do answers on the quiz and talk about that from the last time. If you guys got any questions. So I should have those graded before tomorrow morning. Adios. See you guys later. Thanks for staying next 2 minutes. Have a good day. We'll see you on Wednesday. Have a good day, Will. Hope good to see you back. You bet, man. Have a good day, guys. Oh, okay. Okay. No problem. Can you like message me or email me from
Yeah. I'll email you.
Yeah, no problem. Just really gotta send me an email. Yeah, just send me a message and I'll get them. No problem.